Hello, it's Mr. Mabry, and we are going to do some quick notes on best practices when graphing. Why don't you pause the video and copy down the basic rubric for a great graph here, and then press play when you're done. Okay, I've assumed you've got this copied down. Notice the title right here is the exact same title that I have you use for your data tables, so you can just copy the same title over. Dependent variable goes on the Y. Independent variable goes on the X. I wish I had a great trick to help remind you when one goes here and one goes here, but I don't. So best of luck in just remembering that the IV goes here and the DV goes here. The hardest thing for you to do in 8th grade will likely be when graphing is to remember when to use a bar graph and when to use a line graph. Now remember, we've already learned that qualitative data that nicely fits into this or that categories, that will always be a bar graph because it is discrete, specific data. And continuous data that talks about a string of information that fits along a line or a continuum, that will always be displayed in a line graph. It is sort of a big deal that you remember which type of graph to make because it doesn't show us a really helpful way to understand our data if you put it in the wrong type of graph. So let's do one, for example. I'm going to scroll down now, and let's do a graph based on the information we talked about for our data table notes. So we'll do the effect of chip type on weight gained. I hope that was our data table title. I'm pretty sure it is. So our dependent variable is going to be right here. It is, and I'll just do it in red because I like that color. Weight gained in pounds. Okay. Oh no. Stretch it out. Weight gain pounds.
I need to custodian to Walker 943, please.
Okay. Weight gained in pounds. And then over here for our independent variable, we are going to be chip type. Now, so I've got chip type. There's no unit to use really right here to put in parentheses because it's just types of chips and it's weight gain. Now I need to look back at my data table to see the data that I'm going to put in here. Okay, I've got my data table that we already have in our notes. It looks like I'm graphing that people who ate Cheetos gained an average of 10 pounds, Sun Chips 9, Ridges 8. And because potato chip types are discrete data, it's either Cheetos or Sun Chips or Ridges. See how I'm making those bars with my hands? I'm going to make a bar graph for these types of chips. Okay, I've looked at my data table and I've got my IVs and DVs filled out. I've got my independent variable groups. I've got Cheetos and Sun Chips and Ridges here. See, I've sort of written them at an angle so I could still have room to write my independent variable below. And then I've labeled my y-axis with the numbers. Now I stopped after 10. I should keep going all the way up, but notice in Microsoft Word, the 9 and the 10, they're starting to not quite hit the line, and I didn't want to throw people off, so I just went from 0 and went up to 10. Now remember, you can space these out in whatever increments you want. You could go 0, and then 2, and then get off that, 4, 6, 8, or like 0, 5, 10. It's whatever scale you want to use, you can use. Now for Cheetos, I'm going to look back at my data table. So Cheetos, it goes 10, 9, 8. So I'm going to take my bar, and why not go ahead and use up a lot of the page? So maybe for Cheetos, maybe I'll do a thickness of 3 because it looks better, fills up the page all the way up to, here we go, grow with me, grow, grow. So there's my 10. Oh no, technical difficulties. Well, you get the picture. All right, now here's our graph, looking at the data from our data table and putting it in bar graph form. Cheetos, people who ate Cheetos got an average weight gain of 10. Who ate Sun Chips, it was an average weight gain of 9. Ridges was an average weight gain of 8. Just a little high. This is a great bar graph. And the reason why it's great is because I know distinctly, okay, I can see the trend here. People who ate Cheetos tended to gain the most weight. People who Ridges gained the least amount of weight. Now, we could have tried to put the same data of 10, 9, and 8 in line graph form. Let's see what that would look like. Now, this I want you to copy in your notes. This I just want you to take in and look. So here's the exact same graph, but instead I've made lines out of it. 10, 9, and 8, those points. So now let's connect the lines. So let's say I do a straight line here, and I connect the line here, and now I'll say, boom, look, Mr. Mabry, it's my graph. And I'd probably say, so what you're telling me is, if I was to eat like part of a Cheeto and a Sun Chip right here, then you would predict that I would lose like 9.5 pounds, right? And you would look at me with this weird look. You're like, what do you mean? You can't eat part of a Cheeto and part of a Sun Chips. It's either a Cheeto or it's a Sun Chip. And I'd be like, yeah, I know. But your line graph says you could eat something here or here or here or here or here or here or here. That's what a line graph is about. It's about anywhere along those points, data could fall. So it doesn't make sense to graph a graph about chips and pounds in line graph form because this isn't a possibility. It's either Ridges or Sun Chips or Cheetos. And since it doesn't make sense, that's why we do discrete data in a bar graph and continuous data in a line graph. This is a tough concept for a lot of students to get, and it's okay. You're going to probably struggle with it throughout the year, and that's fine. But as long as you remember this general format right here, you should be good to go. Let's get to work.